Welcome to our today's class. Today we focus on one method of computing the coefficient of correlation between x and y, and we look at Karl Pearson's coefficient of correlation. How do we compute it? Now we just note that the Karl Pearson correlation coefficient helps us to measure the strength as well as the direction of a linear relationship between two variables x and y. When it is negative, it means that x and y are moving on the different direction. That is, they are negatively correlated. When it is positive, then it means x and y are moving on the same direction. Now, the Karl-Pearson correlation coefficient is computed from this formula that we have given here. It's computed from this formula. We have simplified it this way. But the top here is expressed this way. That is, we will sum the product of x and y, and then subtract the product of the individual sums of x and y. And that one we call it the covariance of x and y. Then we shall divide the covariance with the standard deviation. So the standard deviation of x and the standard deviation of y. Now, the standard deviation of x when you square becomes variance. So the variance of x is expressed this way, while the variance of y is expressed in the other way around. Now, n, in this case, the n that we are using, the capital N that we are using, is the number of pairs of x and y that we shall be given. Now, just to do a simple interpretation, is that in case we calculate and we realize that it is between 0 and 1, not 0 and not 1, then it means the two variables are positively correlated. They are moving in the same direction. Positively correlated means it is like that. Now, if x and y gives us a value that is equal to 1, then it means they are perfectly positively correlated, meaning an increase in x causes equal increase in y. Now, if the range is -1, not exactly 1 and not exactly 0, then it means the two variables are negatively correlated, meaning that it will move like that, being y and that being x. One is increasing, the other one is decreasing. When it is exactly 1, -1, it means that they are perfectly negative, equal change, but on opposite direction. When it is 0, it means that the two variables are not correlated. Let's see how we calculated that. An example. Now, when we are calculating, suppose we are given an example that is up there, that these are the values of x and these are the values of y. That is, when x is 0, y is 2. When x is 2, y is 4. So we create columns like this. A column for x, column for y, then the product, y squared and x squared, so that we are able to get the totals for these rows. So once you have done like that, you write these values of x here, translate them from the row to column. So 1 comes there, the 0 comes there, the 1 comes there, 2 comes there, like that. Then you add. When you add, you get 10 there. Then you take y, you put it the same way, you add, you get 20. Then you get the product of x and y, the product of x and y. This times this to give you 0. This times this to give you 3. This times this to give you 8. And this times this to give you 15, or like that. And then you get the total. Now, to get x squared, simply square that column. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. While 4 squared is 16. Then y squared on the other side, when you square now the y, this 2 square, it gives you this 4. All the way up to 6 squared to give you that is 6. And then you add. These are the summations of those values. Now, to get the covariance of x and y, the SXY, you count how many pairs were we given. 1, 2, 3, 4, and 5. So our n is 5. So I put n there, 5, into bracket. What is the total for x, y column? The total for x, y column is 50. I put 50 there. Now, minus the sum for x. What is the total for x column? 10 here. And what is the total for y column? It is 20 here. So I put them, and then I multiply and subtract. I get 50 there. Same to the other one. I put 5 there because the n is 5. Then the sum for the total for x squared is 30. So I put that there, minus. I get the sum for x, which is 10, and then I square. I might multiply it by twice. I square. I either square, I might multiply 10 times 10 to get, when you do that, you get 50. And I come to y. Y here is, the n is 5. Y squared column is 90. So that is 450. Then summation of y. The column for y is 20. So 20 times 20, 20 squared is 400. I get a difference of 50. Then I come now and replace them here. The first one is 50. This one here. The second one is 50. This one here. And the third one is 50. This one here. And then I get them the square root. It's good to note that this is a square here and there is a square here because we are talking about variances. So when you put them inside here and you simplify, you get the get the correlation coefficient S1, meaning that it is perfectly positively correlated. At your free time, you can try to see whether you can do this by assuming the price is the X and the supply, unit supplied is Y. When you look from the diagram, it looks as one is increasing, the other one is increasing. So from the look of the diagram, you are likely to get a positive correlation. Thank you very much, and see you in our next class.